Is it the stress that produces strain or vice versa? Strain is the response of a system to an applied stress. When a material is loaded with a force, it produces a stress, which then causes a material to deform. Engineering strain is defined as the amount of deformation in the direction of the applied force divided by the initial length of the material. What is the difference between proof resilience and modulus of resilience? Strain energy stored in a specimen when strained within elastic limit is known as resilience. The maximum energy stored at elastic limit is known as proof resilience. The proof resilience per unit volume or strain energy per unit volume is what we call modulus of resilience. The answer to this question would be proof resilience is the maximum strain energy that can be stored in a material without permanent deformation, whereas modulus of resilience is the maximum strain energy stored in a material per unit volume. What is hoop stress and longitudinal stress in a thin-walled cylinder? The hoop stress is the force exerted perpendicular to the axis and the radius of the object in both the direction on every particle in the cylinder wall, whereas longitudinal stress is defined as the stress produced when a pipe is subjected to internal pressure. The direction of the longitudinal stress in a pipe is parallel to the longitudinal axis of its central line axis, which means that the stress acts in the direction of the pipe's length. The answer to this question would be when a thin cylinder is subjected to internal pressure, longitudinal and hoop stress are observed in the cylinder. Hoop stress is the circumferential normal stress developed at the tangential direction. Hoop stress acts towards the circumference perpendicular to the length of the cylinder, whereas longitudinal stress acts along the length of the cylinder. The hoop stress is given by sigma suffix h is equal to Pd by 2t, and longitudinal stress is given by sigma suffix L is equal to Pd by 4t. Here P is the internal pressure, d being the internal diameter, and t is the thickness.